All right, example 4.6, a traffic light at rest. We have a traffic light weighing 100 newtons hanging from a vertical cable tied to two other cables that are fastened to a support as in figure 4.14a. The upper cable makes angles of 37 degrees and 53 degrees with the horizontal. Find the tension in each of the three cables. I'll start by drawing a fairly big diagram um, with T1, T2, and T3. And basically our interest is in this point here because this is where all of the forces, the tensions meet. Let's first draw a straight line up here, connect those, and note that these angles were, actually, you know what? I'm not going to look them up yet. I'm going to call this theta 1 prime and this theta 2 prime. And what I'm going to do is I'm going to also draw another line right here. And instead of using theta 1 prime and theta 2 prime, I'm going to use theta 1, which is a angle from the x-axis, counterclockwise from the x-axis. And here, theta 2, which is the angle of T1. I'm sorry, this should be theta 2 and theta 1. So theta 2 is associated with tension 2 and theta 1 is associated with tension 1. A couple of basic reminders about some geometry. If I have two crossing lines, then the opposite angles are the same. So this one's theta 1 and this one's theta 1. This one's theta 2 and this one's theta 2. And also if I have two parallel lines, this one and this one, then I can state that this angle, this angle, this angle, and this angle are the same. And this angle, this angle, this angle, and this angle are the same. I can also note that any adjacent pair made up by that have their boundaries on a line, theta 1 plus theta 2 here is 180 degrees. So I'm going to go ahead and draw on through this line and note that theta 1 prime is the same as theta 1 prime. So theta 1 is equal to 180 minus theta 1 prime. Also, theta 2 is the same as theta 2 prime. So we can notice those things. Now let's break T1, T2, T3, and maybe their sum into their x and y components. T sub x, T sub y, and even theta, T, the angle of the theta. So T sub 2, or well, T3, first of all, was 100 newtons straight down. So I'm going to write negative 100 there. And I know that that the rope wasn't accelerating, so I can actually say that the sum is 0 in both of those directions. Now, T3 in the x direction is also 0 because it's not pushing to the left or right. It was hanging straight down. So I'll come back to the problem again and remind myself what theta 2 prime and theta 1 prime were, 37 and 53. So this is 143 degrees for T1 and 53 degrees for T2. And if we want, we can put in negative 90 degrees for T3 because it is going straight down. So T1, its x component is T1 times cosine of 143. T2, its x component is T2 times the cosine of 53. So those two wires are pulling apart from each other, and this have to be equal to each other. So we could solve this equation here. Cosine 143 is negative 0.799. Cosine 53 is positive 0.602. So solving this, add 0.799 T1 to both sides. Then divide both sides by 0.602. And we find that T2 is equal to 1.33 T1. So now I can fill in the next column. This T1 cosine 1, T1, okay, this is sine 143. T1 sine 143. And T1, T2 sine 53. But I could even replace that here with 1.33 T1 sine 53. And then I'm going to rewrite this equation, T1 sine 143 plus 1.33 T1 sine 53 minus 100 equals 0. So the sine of 143 is 0.602. 1.33 times the sine of 53 is 1.062. And then minus 100 is minus 100. So I add 100 to both sides. Combine the like terms. 1.062 plus 0.602 is 1.664. And divide by 1.664, and I get 60.1 newtons. Then I take that number and plug it in back here to get T2 equals 1.33 times 60.1, which comes out to be 79.9 newtons. Want to show you another way to do this problem with matrices. This is a linear equation. So the basic way you can tell that it's a linear equation is that you can do this. You can put your T1 and T2 over there. You can put your constants over here. That we are going to have this T3 coming out. And I'm putting it as positive because instead of putting the 0 over on the constant side, I'm putting the constant negative 100, subtracting it from both sides. But then the first equation is going to be cosine of 143 times T1 plus sine 143 times T2. So cosine 143, no it's not. It's coming down this way, I'm sorry. T1 and then T2 times cosine 53. Okay, and then the next equation is T1 times sine 143, plus T2 times sine 53, so sine 53 times T2 equals minus 100 equals 0, but it will be 100. So then from there, it's going to depend on your calculator. You make a matrix A, make it a 2 by 2, and then you can just enter cosine 143 cosine 53, I'll just do it, cosine 53, sine 143, and sine 53. And you can see those numbers there popped up as we saw them before. Exit and matrix B. Put in here a 2 by 1 matrix, does rows by column, and then we put in a 0 and 100. 0, enter, 100, enter, and check that that's right. And then exit, exit, and we want to do option matrix, matrix alpha A, and we need to find the inverse key, shift inverse, and then matrix alpha B, and that gives us our values for T1, T2, equals 60.181 and 79.863.